Please take image and calculate the equation.
Sure. I'll take a photo for you in just a moment. This photo shows the expression divided by, let's solve it. 5 squared is 25. So the top is 2 plus 12. 25 equals 39. The bottom is 16. 5 equals 21. So 39 divided by 21 simplifies to 13 sevenths, which is approximately 1.86. The background looks like a mechanical structure with a bright light. Would you like...
Hello friends, today we are going to build something even more exciting. What if I tell you that you can run AI on an ESP32 and not just voice but with a camera? Yes, a small microcontroller with Wi-Fi and a camera can capture images, understand them, and respond intelligently. And the best part? No complex coding required. In this video, I will show you step by step how to turn your ESP32-S3 camera board into a smart AI vision device. Let's get started. To build this AI system, we need ESP32-S3 camera board, 1.8-inch TFT display, INMP441 microphone, MAX98357 audio amplifier, speaker, jumper wires, USB cable, and breadboards. So before we jump into coding, camera, or USB features, let's first understand the hardware of this board properly. Because once you know the hardware, everything else becomes very easy. This section covers the ESP32-S3 camera board in detail. You can skip ahead if you want to jump straight to the setup. Now let's start with the most important part of the board. The shiny metal module right here. This is the ESP32-S3 room module. This module is basically the brain of the entire board. And now, just like the classic ESP32, this metal cover is not just for looks. It acts as a heatsink and also as an RF shield. So when Wi-Fi, Bluetooth, or USB is running, this shield helps reduce heat and also protects the signals from external interference. And on the same metallic shield, you can see N16R8, which tells us the internal memory configuration of this ESP32S3 chip. Here, N16 means the chip has 16 megabytes of flash memory, and R8 means it has 8 megabytes of PS RAM integrated inside the package. Now let me remove this. Quick warning though, don't try to remove this shield unless you really know what you're doing. Inside this metal shield is the actual ESP32S3 chip along with flash memory, and in some variants, external PS RAM as well. Inside this module, we have a dual-core processor that can run up to 240 MHz with built-in Wi-Fi and Bluetooth. But the big upgrade with ESP32S3 is that it's specially designed for USB, camera, and AI-based applications. That's why you'll see features on this board that were not available on older ESP32 boards. Now, one of the most important features of this ESP32S3 board is the camera connector. Right at the center of the board, we can see this camera connector. This is a 24-pin FPC camera interface, which allows us to directly connect several OV series camera modules. Now, near the USB ports, we have two important buttons. The first one is the boot button, and the second one is the reset button. The reset button simply restarts the board. So whenever your code gets stuck or you want to restart the program, you can just press the reset button. The boot button is mainly used while flashing or uploading new firmware. For now, you don't need to worry too much about it. We'll use it step by step in future videos. On the board, you'll also notice a few indicator LEDs. There is a power LED that shows the board is on. And there are TX and RX LEDs that blink during serial communication. So whenever data is being sent or received, you'll see these LEDs blinking. The board also has an LED connected to a GPIO pin, which means you can control it directly from your code. And along with that, there is an onboard RGB LED, which is also connected to a pin on the board. Now, on the same board, you'll notice that we actually have two USB ports. The first one is the USB OTG port. This USB port is directly connected to the ESP32S3 chip itself. That means this port supports native USB communication. Using this port, the ESP32S3 can work as a USB device, like a keyboard, mouse, or even a USB audio device. It also allows direct programming without any external USB to serial converter. This is a big advantage of ESP32-S3 compared to older ESP32 boards. The second USB port is the USB UART port, which uses CH343P USB to serial chip. This port is mainly used for uploading code and also for serial monitoring and debugging. So depending on your use case, you can use either USB OTG or USB UART. Now if we turn the board to the backside, we can see some important components here. First, we have the 1117 3.3 voltage regulator. This regulator converts the 5 volts coming from the USB into a stable 3.3 volts. And this 3.3 volts is required by the ESP32-S3 and other components on the board. Next to it, we have a 100 microfarad tantalum capacitor. This capacitor helps in smoothing the power supply. It also provides stability, especially when the camera or Wi-Fi draws sudden current. Here we can also see the CH343P chip, which is the USB to serial converter. This chip allows the board to communicate with your computer for programming and serial monitoring. Apart from this, there are some supporting components for the camera interface. These components help in signal stability and proper communication with the camera module. And finally, on the backside itself, we have a micro SD card slot. This allows us to store images, videos, logs, or any other data directly on an SD card. And here you can see the pin symbol notations, which show whether a pin is used for the camera, SD card, or PSRAM. Alright, now let's talk about the pins on this board. If you look along both sides of the ESP32-S3 development board, you'll see long rows of pins. On this board, we have 20 pins on each side, so all the important GPIOs are broken out neatly. These pins are called GPIO pins, which stands for General Purpose Input Output. And this is how the ESP32-S3 talks to the outside world. Using these GPIO pins, we can do a lot of things. We can read a button press. We can turn an LED on or off. We can control a motor, or we can connect sensors, displays, and other external modules. Now, if you look closely at the pin labels, you'll see some power pins as well. Here you can see the 5-volt pin. This means you can drive 5 volts from the board to external devices. And you can also give 5 volts externally to this pin in case you are not powering the board using USB. Next to that, we have the 3V pin. This provides a stable 3.3 volts, which you can use to power external sensors or modules. And here we have ground pin. Now, here's something very important to notice. Some of the pins on the side headers are actually connected to the camera interface. If you look closely at the board, you'll notice a symbol printed below these pins. These pins are reserved for camera signals. So when you're using a camera module, make sure you do not use these pins for any other purpose. Using them incorrectly can damage either the board or the camera module. Now, similar to the camera pins, you'll also notice some pins on the header marked with another symbol. These pins are connected to the onboard micro SD card slot. Internally, these pins are used for SD card communication. So when you are using the SD card, these GPIO pins are already in use. You should avoid connecting any other external components to these pins at the same time. So if you are not using the camera or SD card, then those pins can be reused, but only if you clearly know what you are doing. Here we can see the complete pin diagram of the board. Now, similar to the camera and SD card pins, here are 3 more pins on the same header that are actually connected to the PSRAM. And honestly, this is one of those things that confuses a lot of beginners. So let's clear it up properly. You might have noticed this on your ESP32-S3 development board. Apart from the flash chip, you can see only one main chip, which is the ESP32-S3 itself, sitting inside that metal shield. So then you look at the board specifications and it clearly says 8 megabytes PSRAM. And naturally, the question comes up, okay, so where exactly is the PSRAM? So here's the answer. Some ESP32-S3 variants come with in-package PSRAM. Now, what does in-package PSRAM actually mean? It means the PSRAM is placed inside the same physical chip package as the ESP32-S3, but it's not part of the ESP32 processor's core silicon itself. Internally, there are actually 2 separate silicon dies. One die is the ESP32-S3 processor, and the second die is the PS RAM memory. These 2 dies are then sealed together inside a single package. So while you are using PSRAM for any requirement, you cannot use these pins for anything else. Alright, it's very important to note one thing here that if you want to use the onboard RX and TX pins as normal GPIO, or if you plan to communicate with other external devices using these pins, you should avoid using the UART port for programming. Instead, you can program and debug the board using the OTG port. This way, the OTG port handles all the programming and serial communication. And your RX and TX pins stay completely free for your own applications. So now that you have a clear idea about the board, let's move on and start building our AI project. Now let's quickly see the circuit diagram. You can follow the circuit diagram exactly as shown on the display. Now let's quickly complete the setup by following the circuit diagram. Once you are done, your setup will look like this. Now that the hardware setup is complete, let's move to the second part. We are not writing any code. Instead, we will flash it using a web browser. Open your browser and go to oceanlabz.in. Then click on the AI tab in the navigation menu. Then click on AI XiaoZhi. And then go to the ESP32-S3 camera with 1.8-inch TFT display tutorial. On this page, you'll find the complete process including circuit setup, web flashing, and configuration all explained in a simple way. Just follow each step carefully. First, here is a short introduction about XiaoZhi AI. You can read this to understand how it works. Next, you'll see the required components, which we have already set up. And here's one important thing. It is recommended to use a zero PCB and solder all the wires properly instead of using a breadboard. Breadboard connections can become loose and unstable, which may cause disconnections or errors. After that, you can see the circuit connections for the INMP441 microphone, MAX98357 Amplifier, and TFT Display. Now scroll down and you'll find the circuit diagram which we already saw at the beginning of the video. Scroll further, here is the connect button. This is basically the firmware flasher. Before clicking on connect, make sure you plug your ESP32-S3 into your computer using a USB cable. Then simply click on connect, select your COM port, then choose install OceanLabz ESP32S3 TFT CAM and start installation. It will take some time. First, it will automatically erase the data and then upload the firmware. And the installation is complete. Now we need to configure the board. On the TFT display, you can see the device name. It will show something like XiaoZhi followed by some numbers. Now here's what you need to do. Take your laptop or your mobile phone, open the Wi-Fi settings. You will see a new Wi-Fi network with the same device name shown on the display. Here, we can see it, XiaoZhi. Now connect to this network. Once connected, open your browser. In the address bar, to type 192.168.4.1 and press enter. Now you will see a configuration page like this. This is the setup portal. From here, we need to connect the ESP32 to Wi-Fi. Select your correct Wi-Fi network from the list. Enter your Wi-Fi password carefully. Then click Submit or Connect. Wait for a few seconds. The board will restart automatically and your device is now connected to the internet. Now, if your device is successfully connected to the internet, you will see a 6-digit PIN on the display. This PIN is important. Now open your browser. In the address bar, type xiaozhi.me. Once the website opens, click on the console button. If you don't have an account yet, you need to sign up first. In my case, I already have an account, so I'll just log in. After clicking on console, a page will open like this. Now click on add device. Here, you need to enter the 6-digit PIN that is shown on your display. Enter it carefully. Once you're done, confirm it. And just like that, you'll see your device added to the dashboard. Now click on configure role. From here, you can fully customize your ESP32 AI chatbot. You'll see some ready-made role templates available. Here, you can assign the name of your assistant. Next, select the language. Then choose the voice you prefer. you can select any voice from the list available here. Now comes the important part, defining the role of your assistant. In this section, you can describe how you want your AI to behave. You can further optimize and refine the role description here. Just make sure to keep the total words within 2000 characters. Below that, you can enable memory so the assistant can remember your previous conversations. And for the LLM, for now, I am selecting XiaoZhi Lite. That's it for now. Click Save. And finally, reset your device.
Hey, please take a photo and describe.
Sure, I'll take a photo for you. Let me capture the moment. I see a man in a gray t-shirt holding a blue and white object, possibly a pen, close to the camera. The background shows an indoor room with a ceiling fan and some furniture, though the view is a bit blurry.
Please capture the photo again and describe.
I understand you'd like another photo. Let me try again carefully. This time, I see a man with a beard holding orange-handled pruning shears close to the lens. In the background, another person in a striped shirt is sitting amidst tools and a green door, giving the scene a casual workshop vibe.
Now I'm going to animate the emoji on the display like this. Simply go to XiaoZhi.me and click on Manage Device. Then click on Theme Setting Customize. Then click on Next. Step 1 is complete. Now in step 2, go to the emoji collection. Under Preset Emoji, select Noto Emoji 64 by 64 pack, then click Next. Here you can also choose your theme mode like light or dark. After that, click on Generate Asset Bin, then click Start Generate. In the last step, click on Flash to Device Online. This may take around 10 to 15 seconds. Once it's done, click on Close. As you can see on the display, the data is being uploaded to the ESP32-S3. And now it's complete. You can see the emoji on the display is animated.